Okay, in this class I'm going to look again at Newton's experimental law of restitution. And in this case I'm going to look at an example where the ball does not strike the plane at right angles. So remember, restitution just means kind of bounciness. That's all it really means. And we have this kind of Newton's experimental law says this: along the direction of the impulse, that the final velocity is negative e times the initial velocity. So another way of saying that is that the rebound speed is equal to e times the impact speed. And speed we're talking about there, as opposed to velocity. So suppose a ball lands on a horizontal floor with a speed of 40 meters per second, and the path of the ball makes an angle of 30 degrees with the floor when it lands. Again, that's only for an instant. Obviously the path of a ball that's launched from somewhere will follow a parabolic path, but we're talking about the instant. At the instant it makes contact, the velocity vector of the ball makes an angle of 30 degrees with the floor. So what we have is something like this. The ball at that moment in time is traveling in that direction when it lands, when the angle it makes with the horizontal is 30 degrees. Okay, and we're also told that it's traveling with a speed of 40. Now, knowing what we know about special triangles, the side opposite 30 is always half the hypotenuse. The side opposite 60 is always the side opposite 30 times root 3. So my initial velocity, or the initial velocity of the ball, is going to be 20 root 3 I hat. And again, depending on how you want to define your coordinate system, I'm defining this as being right positive, up positive system. So that 20 there is a downwards velocity, so we're going to have minus 20 j hat, and that's going to be my initial velocity. That's the velocity on landing. If you don't know your special triangles, remember opposite is always hypotenuse times sine of the angle. 40 sine 30 gives you 20. The adjacent is always the hypotenuse times cosine of the angle. 40 cosine 30 gives you 20 root 3. The key detail here is that the impulse is imparted perpendicular to the floor, perpendicular to the plane that the ball is striking. So if I just put in an arrow to show you the impulse will be taking place in that direction there, which means that the horizontal component of the velocity vector will remain unchanged. So after impact, the horizontal component of the velocity vector is going to still be 20 root 3 I hat. The other thing that happens is it's going to turn around. It's going to turn around. It's still going to have that same horizontal component, 20 root 3, but now it's going to turn around and it's going to lose a little of its vertical speed. So it's going to be something like that, say. That's going to be my velocity vector, again immediately after impact. So what we're trying to do is find the velocity. I have the I component, so I just need to find this j component here. And how do we do that? Well, we know along the direction of impulse that the final velocity is negative e times the initial velocity. So perpendicular to the plane, the final velocity is going to equal to negative e times the initial velocity. Negative e, well, e is 0.75. And perpendicular to the plane, the initial velocity was negative 20. So we're going to get negative by negative, that's a positive. And now we're talking about 3/4 of 20. 1/4 of 20 is 5, so 3/4 is 15. So plus 15 j hat meters per second. So note, to find the rebound speed, it's always e times the impact speed. E was 3/4, so the rebound speed is going to be, again, I'm just talking about the perpendicular component, that vertical component. The impact speed along the perpendicular was 20. The rebound speed is going to be 3/4 of that. 3/4 of 20 is 15. So my final velocity immediately after impact is 20 root 3 I hat plus, because it's turned around, and this is how I've defined my coordinate system, plus 15 j hat meters per second. You can find the speed of the object by taking the square root of its I component squared plus its j component squared. And you could find the direction of the object by taking tan inverse of 15 over 20 root 3. So theta there would be tan inverse of 15 over 20 root 3. And the speed, the magnitude of the velocity, would be equal to the square root of 15 squared plus, make sure you put the 20 root 3 inside the bracket, squared. Okay, that will be the speed and direction after impact, direction above the horizontal. Okay, so that's how we address problems when the ball does not strike at right angles. The key detail is the impulse is imparted perpendicular to the plane. So Newton's law of restitution is applied along the direction of impulse, which is only perpendicular to the plane. Okay, so we're looking at 7A in our textbooks. Practice, practice.